Question number 76. Correct order of boiling point is. We have different compounds given here. Let's check what are these compounds. One is methanol. Methanol is here. Then ethylene glycol is here. Then ethanol is here. Three compounds we have, and in these three compounds we have to check what would be the order of boiling point. We know that boiling point depends on the molecular mass of the compound, for first thing. Further, it also depends on the molecular association. In all of these compounds, these all are alcohols, they have hydrogen bonding. We have to check that molecule in which hydrogen bonding is maximum. So what's the structure for this methanol? This is CH3OH. It shows intermolecular hydrogen bonding, but we have to check further also, that is ethylene glycol. Structure is like this, and further is ethanol. In case of ethylene glycol, the extent of hydrogen bonding is maximum. Why? Because it will show the hydrogen bonding due to the presence of two alcoholic groups. One is this, another is this. So maximum boiling point would be there for ethylene glycol. So what would be the correct order? Maximum boiling point for ethyl glycol. Where this is given? If you check the given options, you will identify that it is given in option 2. And on the basis of this, this is the correct answer for this question. I hope this question is clear to you. Let's check next question. Question number 77. Select the correct statement about the orbital overlap in NSiH3 whole thrice and PSiH3 whole thrice molecules. We have two different molecules and we have to choose a correct statement about them. First we have NSiH3. I'm just drawing its structure. This is NSiH3 whole thrice. Then phosphorus also has a similar type of bonding. Now, in case of the first compound, in case of NSiH3 whole thrice, there is the nitrogen atom which has the nature to form the back bond with the silicon. Basically, this back bond is formed between p pi orbital of nitrogen and d orbital of Si. So that is the orbital overlapping. In this case, nitrogen has its p orbital while the silicon has the empty d orbital present here, and there is the back bonding of electron. This lone pair of nitrogen is shared with silicon to form p pi d pi back bonding. While in this case, extent of back bonding is less due to large size and less electron density on phosphorus. Let's check the options given here. This NSi, axial and sideways overlap, this is true. If we talk about PSi, only axial overlap, no, there would be both axial and sideways overlap. In case of NSi, only axial overlap, that is also wrong. And PSi, only sideways overlap, this is also wrong. So these three statements are wrong, while this first statement is the correct one. That's why I'll choose it as the correct option. After this, it's a turn for next question. Question number 78. How many bond angles are of 109.28 degree in one CH4 molecule? In this case, we have to consider the CH4 molecule. There are 4 hydrogen atoms which are directly attached with carbon atom. In this case, this angle is 109.28 degree. This is also, and this is also, because tetrahedral angle is there. Now, there is one bond between these two, and here is same one bond would be here also. So total 6 bonds are there which have the bond angle 10 degree 28 minutes. That is why I'll choose option 4 as the correct option. Now, after this, there's another question. Question number 79. For the formation of stable ionic compound, Basically, when we want to form a stable ionic compound, there are three types of energies which are involved. So first is ionization enthalpy. The second one is for the formation of anion, that is called electron gain enthalpy. And the third is lattice enthalpy for the formation of ionic lattice. These three energies are required, and the total amount of energy which is required should be less than the total amount of energy released. In that case, definitely a stable ionic compound would be formed. So, if we talk about the options, first statement says total energy released is greater than the total energy absorbed. It's correct statement which is given here. Further, ionization enthalpy should be negative. Ionization enthalpy is positive for the formation of cation because that amount of energy you have to provide. So this statement is wrong. Electron gain enthalpy should be positive. Electron gain enthalpy for a non-metal is generally negative. So this provides the amount of heat there, and this statement cannot be joined with the statement given here. Further, formation of ionic lattice should be endothermic. Only lattice energy cannot be considered. This is not correctly complete this statement. So which statement is correctly completing this statement given here? For the formation of stable ionic compound, total energy released is greater than the total energy absorbed. This is the correct one. And I'm just going to choose it as the correct statement here. That is my correct answer. Now, after this, we have the next question. Number of lone pairs of electron present on central atom in XiOF2 is. To identify the number of lone pair of electron on this given molecule, we have to draw its structure. Let's draw its structure. Its hybridization is sp3 dehybridization, and on the basis of that, its shape we can draw here. This is XiOF2. So there are the two lone pairs in this way. This is the structure, and you can clearly identify the total number of lone pair present here. Two lone pairs are present, and this is our correct answer also. And let's check question number 81.